Hello and welcome to this quick look through a multiple choice question which tests your knowledge of polarity and haloalkene stereoisomerism. So, before we start, it's important to assume that you have some background knowledge on EZ stereoisomerism and how we assign polarity in molecules. Because of the time limit on the left-hand side of the screen, we can't really spend too much time reviewing these, so it's not a review of them, it's just applying them. So this is our question. First thing to have a look at is the fact that they want you to identify nonpolar molecules. So it means no overall polarity, so the dipoles will cancel out. So looking at an example, tetrachloromethane, although there are polar bonds, which you can see here, obviously the CCl bonds are polar because of the dipoles, they act in opposite directions to one another. So we can put in these little arrows with a bar through them to represent the direction in which the dipoles act, so they all cancel one another out. So the molecule is not polar overall. However, in a hydrogen chloride molecule, it is polar because the dipole acts from left to right, so there's a slightly negative end and a slightly positive end. So let's look at each molecule in turn before deciding which one to go for. Going for E12-dichlorobutene, that's the structure. So because you've got polar bonds here and here, they tend to be situated to the left of the molecule, so therefore the direction of the dipole acts from right to left. So this is a polar molecule. That takes this out of consideration. Let's look at Z2,3-dichlorobutene. We can predict that C can also be eliminated because the low count numbers of the chlorine atoms suggest it's asymmetrical. So why is this? Let's look at the direction of the polarity. This is the slightly positive end. This is the slightly negative end. So therefore the dipole acts in the direction of the chlorine atoms. So that's a polar molecule, so we can't consider that one either. Next two are a little bit harder. Let's try to work this out. Going for Z14-dichlorobutene, you can see that what's happening here is, again, we've got a slightly negative end and a slightly positive end because of the location of the chlorines in this line of symmetry. So it can't be this one either. So let's just check why it's B, not just by a process of elimination. So E2,3-dichlorobutene is like this, and if we put in the dipoles individually, you can see that they point in opposite directions. So therefore, the dipoles cancel out. So this is the answer. Okay, thanks for listening. Hope these have been useful. Until next time, see you soon.